Professor Jonathan Napier, a pioneer in plant biology based at Rothamsted Research, and leading fish nutritionist Professor Douglas Tocher from Stirling University, have been collaborating for nearly 20 years on finding a sustainable solution to deliver novel sources of omega-3 fatty acids. The oceans are under relentless pressure as the world population grows, and we increasingly look to fish as an important food supply. Alongside this is our increasing reliance on fish to provide us with omega-3, a polyunsaturated fatty acid that our bodies need to function. It has led to the quest to find a sustainable source of fish oils, and the unlikely solution could come from a plant called Camelina. Professor Napier has carried out field trials in the UK to create the plants. The crops have been genetically modified, enabling them to produce these particular omega-3 fatty acids in their seed oil, something no other plant can do. Together they are embarking on a new aqua feed trial, delivering an alternative fish feed solution, using a genetically modified oil ingredient to Atlantic farm salmon, which they hope will relieve the pressure on stressed marine resources.
So we've been interested in trying to work out how could we make a new land-based source of fish oil so we could basically secure the supply of these really important nutrients in a way that's not going to be taking them out of the ocean, but making them on land, using agriculture to produce them. And so we spent probably a decade trying to develop plants to do that, and we were successful through support from BBSRC. And now we're in a position to actually test those land-based supply of fish oils in aquaculture.
Omega-3 fish oils, also known as omega-3 long-chain polyunsaturated fatty acids such as EPA and DHA, have been proven as beneficial to human health, reducing the risk of cardiovascular disease and other metabolic diseases. These oils are credited as being crucial for human nutrition, but the wild fish stocks which provide them are at maximum levels of managed sustainability, meaning the current fish stocks are simply not able to provide enough nutrition for a growing global population.
For the fish to have them in their flesh, they have to be fed them. And so we've been using fish meal and fish oil, but they are also at their sustainable limit. So in the last 10 years, in a drive to make fish feeds and salmon feeds more sustainable, we've been increasingly replacing fish meal and fish oil with terrestrially derived products like plant meals and vegetable oils. And unfortunately they don't contain any long-chain omega-3 polyunsaturated fatty acids. And so because they don't contain any, the levels in the fish are also declining. So over the last 10 years the levels have declined by about a half. So when you have a portion of salmon today, it's maybe got about half the level of EPA and DHA, these long-chain omega-3, that they used to have 10 years ago.
Walking around the trial site, it's clear Professor Napier is enthusiastic about the latest stage in this ongoing research using the Camelina plant.
For me, it's also the culmination of a lot of research to get us to the point here where we're going to test our plant-derived omega-3 fish oils in a salmon farm to see how they perform. And we're going to do this for at least a year to feed the diets to the fish. So it's really exciting.
The young fish have already been added to the pens, in which they'll be fed and monitored during the course of the trial. The pens are outside in seawater and are being fed and monitored by a team of experts. Nearby there are salmon that will be fed normal fish feed, so that the two can be compared. The team looking after the fish ensure they're fed regularly throughout the day, and the amount of food not being consumed is monitored using underwater cameras.
Simply by looking at their behaviour and their activity, their feeding behaviour, feed intake, anything that shows up there will be able to be monitored on a daily basis. Regular intervals the fish are weighed, and so the fish get inspected more closely at that time. And also we will be taking samples at intervals in which we will be able to determine physiologically and biochemically that these feeds are having no negative impacts on the fish health.
During the course of the trial, Dr. Monica Betancourt, a research fellow at Stirling University, plays a crucial role by checking on the salmon's health and collecting data.
What I do when I come here is take the different samples that we need for the analysis. In this case, we'll be assessing both the performance of the fish, so it will be from simple biometry, so measuring the fish, weighing them just to see how the growth is, if there was any difference between the fish fed the commercial diet and the fish fed the diet with the new Camelina, and also getting different type of samples that will help to see how the fish are accumulating omega-3 in their different tissues, also to see the impact that the diet can have from a molecular point of view, and also to assess the health of the fish.
The success of this trial is fueled by the determination of both professors to return to levels of omega-3 fatty oils in farm fish to those of a decade ago.
And we expect that the fish at the end of this trial will have pretty much the same levels of EP and DHA that farm salmon had about 10 years ago, which is a tremendous benefit to the consumers.
Professor Napier is keen to stress that the results of the trial should complement and not replace existing aquaculture activities. If successful, the project could provide a potential solution to the sustainability issue in supplying fish oils to farmed fish.
This is a really significant activity for us, because it'll demonstrate that we can use our omega-3 fish oils from plants across the whole life cycle of the salmon production season. And so once we know that really gives us the demonstration, the proof that this really is basically a solution to this sustainability issue that relates to the supply of fish oils. And so for us then, the next activity would be to think about, okay, how can we move this into actual commercialization? How can we commercialize this technology so that we deliver impact?
The farmed salmon here in Scotland could help provide the solution to relieving pressure on the world's stressed marine resources.